Now I am going to cover minimal cover topic. The definition for minimal cover is a minimal cover of a set of functional dependencies. E is a minimal set of dependencies in standard canonical form and without redundancy that is equivalent to E. Irrespective to the definition, let's go directly to the problems. The problems we can easily understand the canonical cover or minimal cover. So we can solve canonical cover problem in three major steps. In 3 steps, let us do an example, then we will go into it. A, B, C, D, E and C, D tends to E. So given functional dependencies are these, so you should find a canonical cover for this or find minimal cover. So how we can write this? Step 1. Step 1, you should decompose this thing. So there is A to B, C, D, E. So this can be written as A to B, A to C, A to D, A to E and C D to E, C D to E, C to E, T to E. We can't write like this. We can't write like this because here CD is consider CD is feeding E. Not C alone is feeding E, not D alone is feeding E. Both C and D together can feed E. So we can't write C to E or D to E, but we can write A to B, A to C, A to D, A to E. Okay, no, we can write C D to E. So this is step 1. After this, step 2. Step 2. 5. Update the table or update the FDs after each iteration. So find the closure of A. Find the closure of A without considering this. So find the closure of A. What is closure of A? A to C, first A to C, A to D, A to E, C D to E. So C D to E. So is there any A to B? Is there any A to B? There is no A to B. So this FD must contain in the set. Then after check, find the closure of A to C. Find the closure of A without considering A to C FD. So A to B updated list, it will be there in the updated list. So you should consider this A to B and A to D and A to E. So there is no CD to E. So is there A to C? Is there A to C? No, there is no A to C. So A to C must contain in the given functional dependencies. Then after find closure of A to D. So find closure of A without considering A to D. So there is A to C, A to B. We can write those two, A to B and A to C and A to E. Okay, that's it. There is nothing more. So there is there any A to D? A to D here? No, there is no A to D. So this set also contains this functional dependency is also contained in the set. So find the closure of A to E. Find the closure of A to E. So without considering A to E, A to B, A to C, A to D, again C D to E, C D to E. So there is E to E, there is E to E. So you can remove this FD. You can remove this FD from the given set of FD. Now write the updated list. If anything deletes, you better you write the updated list immediately after. A to D, A to E. No, there is no A to E. It is deleted here. C D to E. This is checked. This is checked. This is the final thing is not, which is not checked, is C D to E. So find the closure of CD without considering CD. CD. Is there anything? C to something or D to something? There is nothing. So there is no CD to E. So this must be contained in the set. So I written in the order CD to E in the last, A to E in the fourth position. The order can be written in any way. So A to E is written in the first. So in the beginning only A to E goes. So like this, any number of students can get any number of canonical cover. So this is the concept of canonical cover. So this is the if this we got after doing this closure thing. So there is CD to E. We can redundant E. We can redundant this also. So you can find the closure of C if it has C to D. You can write this. You can remove D and can write it can write it as C to E. Understand? So or vice versa. Find closure of D. Do this and after that do this. Find closure of D if it has C in its closure. You can remove C and you can write it as D to E. I hope the thing is clear. So find the closure of C here. Find the closure of C. There is nothing. Hide this and you can find nothing. Find the closure of D, and same ways you can find nothing except this. So there is no C to D. There is no D to C. So C D to E must be there. So this is the final canonical cover you require. So A to B, A to C, A to D can be written as A to B, C, D and C, D to E. So this is the final canonical cover of the given set attributes, set of functional dependencies. Thank you.